So today we're looking at beam deflection. It's called Introduction to Structural Member Properties. But what we're looking at is how strong a beam of wood is, let's say, or steel or anything. Right now, mainly just wood. And one of the things to look at when you're looking at wood is, of course, what type of wood and stuff like that. But moment of inertia has nothing to do with what type of wood you have. Of course, some are stronger than others. That's a whole different property. We'll talk about that tomorrow. Today, we're just talking about pretty much like how thick the wood is, right? But not only how thick the wood is, but its orientation, and we'll talk about that in a second. So, of course, like a little thin stick is weak, and a big, gigantic, thick log is strong. But also, if you do have like a big 2x4 or something like that, it does depend which direction you hold it, and it does become stronger. It, so moment of inertia is the stiffness of an object related to its shape. In general, a higher moment of inertia produces a greater resistance to deformation, so it doesn't want to bend as much, in other words. So if you look at these two, I asked the class, and the class thought at first that this one would be stronger. And you would think so because everything you walk on looks like this, right? So of course you might think that. But no, this one is much stronger. These are both the same piece of wood. You just rotate one down this way, and it's called a plank. If we hold it in this direction, it's called a joist. And this one is much stronger than this one, even though they're both same piece of wood. Look at, they're both Douglas fir material. That's the type of wood, Douglas fir. And then they're both 8 feet long. But the difference is the width and the height are reversed. You see this? One is 1.5 width and 5.5 height. The other one is 5.5 width and 1.5 height because the way they rotated it, right? But the area, like if you just look at the area, 1.5 times 5.5, the areas are the same, of course. It's just that this right here, the way they're designed is different. So which one bends more? This one right here, the plank. The plank bends a lot. It's real wobbly that way. You try to stand on this, it's going to bend. You stand on this one, and I don't know if you can see, it's actually bending, but not very, very much. Just like a quarter of an inch or something, or half an inch. This one bends multiple inches with the same amount of weight. Why did it bend so much? The difference of moment of inertia is due to the orientation of the beam, the way it's set up. And calculating the moment of inertia of rectangles is done like this. This is the equation. You take the base, how wide it is here, and you multiply it by the height cubed though. Okay, so that's cubed. And that means we have to times the height here, whatever that number is, by itself 3 times, then times it by the base, and divide it by 12, and that's always 12. So really you just need these two things. You just need to know the base and the height, and you can calculate the moment of inertia of a material. Let's look at this one, calculating beam A. Remember, this was the joist because it's standing this way. When you stand up on it right here, you put your foot up here, it's going to be really strong. And that's because it's got this 5.5 right here. So let's look at it. Set up the equation. Remember, the height is cubed. So there's the height, 5.5 cubed. That's that. And then times it by 1.5 right here. That's the base. So if you times this by itself 3 times, you get this number. Go ahead and do that in a calculator if you like. Then take this number and times it by this number, 1.5, and you get this number on top. Finally, take this number and divide by 12, and you'll get your answer 21 inches to the 4th power. That's just a unit for moment of inertia. So this is rounded, by the way. I think you get like 20.8 or something like that, but if you round up, you get 21. So 21. That's the moment of inertia on this guy. Let's see if we rotate it this way. Same piece of wood, but we're laying it sideways. Now the height is only 1.5. See right here? The height's 1.5. But the base is bigger, 5.5. What happens when we cube that 1.5? Let's see. It's 3.375 when you times it by itself 3 times. Now let's take that number and times it by that number. 18.5625. Okay, let's take this number and divide it by 12. And that's our last step, and our answer is 1.5. Much weaker. Look at this. One is 1.5, the other one's 21 inches. That is 14, this one's 14 times stiffer. Just take 21 and divide it by 1.5, and you'll see it's about 14 times stronger. In other words, 14 times less likely to bend. Or you can say that this one is going to bend 14 times more than this one. It will. So this one's going to be much more flexible. And sometimes when you're building homes and stuff, you don't want them to flex that much. So now let's look at your homework. So in your homework today, you just have to do these 2 rows right here. Do not do, can I write on this? I cannot write on this. But So do not write on this last row. We're going to do that tomorrow. Okay. This is going to tell us how much it bends, but we don't need to know that right now. So we're just going to do the cross-sectional area and this. I'm going to do this one as a sample. Cross-sectional area for all of these are going to be quite simple. You just take these two numbers and multiply them. So here's a common name, a 2 by 6. Just to let you know, common names like 2 by 4s and stuff have these names, but the actual sizes are always a half an inch smaller. That's just the way lumber is. It's the way they're milled. And the reason being is, if you want to know, is they take a 2 by 4 piece of wood, but they're really raw and ugly, and then they want to clean them nice and smooth, so they take off a 1/4 inch on one side, a 1/4 inch on the other side. That's a total of a 1/2 inch. Then on the other two sides they do the same thing, 1/4 inch off each side, and sand it down, kind of, let's say. They use like something called a planer, and they kind of like sand them smooth, taking a 1/4 inch off both sides, which ends up taking a 1/2 inch off the entire dimension over that side. So therefore you end up with a smaller piece. It's still called a 1 by 4 or a 2 by 4 or 2 by 6 right here, but it's a 1/2 inch smaller in each way. Alright, so let's do this one, 1.5 by 5.5. Let's do that. I don't need my calculator right now, but we do know that, first off, they did show in the picture that it looks like this, but for cross-sectional area, it doesn't really matter what shape it is. So, but like the, I'm sorry, the orientation, but that's 1.5, that's 5.5, and the cross-sectional area, cross-section area, oops, gotta spell that right, is just equal to the 2 times each other. That's it. So there we go. Oops, that's not the answer. I gotta actually calculate that, don't I? So let's go 1.5 times 5.5, and the answer is 8.25. And the answer is 8.25 inches squared, because it's just an area, and you guys know areas are squared. So that's it. And it wouldn't matter which way. If it was laying flat like that, it wouldn't matter which way, because you're just taking the two numbers and multiplying them, and that's it. So the cross-sectional area, so let me see if I can bring that back over here. The answer here, and let me see if I can end up writing on this, drawing it. Let's see. I think this should let me. The answer here is, I lost it, 8.25. There we go. 8.25. Except you will write a little bit neater in there. 8.25 inches cubed. Now, what is the moment of inertia? So moment of inertia, I, is equal to base times height cubed divided by 12, and the base right here is 1.5, right? This is 1.5, the base. So 1.5 times h, 5.5 cubed, because remember, this is the height right here, this distance here, 5.5 cubed divided by 12 every time. So let's take this, first we've got to always cube that first. So let's bring out the old calculator, and you can do, there's 2 ways to do this. You can go 5.5 times 5.5 times 5.5, and we get 166,375. So by the way, I'm going to try to do my work over here and see if I can bring this down a little bit. There we go. And so that's 166, I forgot the number already, 166,375. 166.375. That's that number cubed. And don't forget, we still have to multiply 1.5, and we'll have to divide by 12 too. The other way, I think there's another way to do it. Let me see. Depends if your calculator has this feature. See, this is a standard calculator, but you can go to scientific, and sometimes you can go 5.5 and then cube it, right? Here's a squared button, and it doesn't look like there's a cube button. So then you can click this number right here, and then say to the 3rd power. So that means to some power, and I'm going to click 3, so to the 3rd power. And there we go, same number, see? So all I did was, again, if you didn't see that, is I just typed in the number I want to cube. I'm going to cube that number. Then I click this, and it says some number to the y power. So I got to say what power, 3rd power, equals that. So that's the other way to do it. Or you can just multiply it 3 times if that makes you happy. Next thing we got to do is times this number by the 1.5. And we get 249,5625. 249 0.5625, I think. I'll just try to remember that. And then divided by 12, of course, don't forget that. So I multiplied these two right now. I just did that. And these are equal to the momentum. Not the momentum, the moment of inertia. And let's just divide them and find out. Let's divide this by 12 and we'll be done. Divided by 12. 20.8, let's round it, or they always round it to these two numbers right here, so I'll just say 21. And I'm fine with that. 21, and what was that unit? Inches to the fourth power. That's the moment of inertia unit. So the answer is 21.4. So if we bring back our little worksheet here, I can type in 21 as the answer. So pretty much this one right here, I'm going to tell you the answer for this one right here. 8.25. How do I know that? How do I know the answer is 8.25? Because look at this. Remember, how do we find this one? Remember, we just take those two numbers and multiply them? Well, these are backwards, but multiplied they're the same, so it's the same thing. Just like, so that's how I found it. This one is going to be different though. So this one will not be 21. I could tell you this, it will be less than 21 because it's a plank, and planks are always weaker than their joist relative, right? So when we lay it this way, the base is really big, sure, but now the height, which is super important, it gets cubed, is small. So this is going to be a small number, maybe 4, maybe I don't know what it's going to be, but it's going to be smaller. I hope that helps. Just fill out these two rows right here. You're just filling out these right here. Okay, do not do that one. That's for tomorrow.